Assalamu alaikum. Hello everybody. So this is module 1, first example. We are talking about interrupts in our course Microcontrolling Start as Professional. So in this example, the first example, we are going to see a simple program to turn an LED on and off using interrupt. So just a quick review. As you know, this is our Atmega 32, which have 3 external interrupt: interrupt 0, interrupt 1, and interrupt 2. Interrupt 0 is connected to port D pin 2, pin 16 here, and interrupt 1 is connected to port D pin 3. Interrupt 2 is connected to port B pin 2. To control the interrupt, we need first to enable the interrupt in the status register. Then we need to decide which interrupt we are going to use. So according to which interrupt we are going to use, we need to enable it again in the GICR. Okay, so this is the GICR. If we are going to use interrupt 0, we need to give 1 to bit 6 in register GICR. For deciding the way the interrupt is happening, we need to use what's called the MCUCR register, which is the microcontroller control register. For interrupt 0 and interrupt 1, they are in MCUCR. So according to the values of ISC00 and ISC01, we control the way the interrupt is happening for interrupt 0. The ISC10 and ISC11 control the way that the interrupt of interrupt 1 happens. For interrupt 2, we have other register, which is MCUCSR. So there's extra S here. It's MCU control and status register. So it has only 1 bit to control interrupt 2, which is ISC2. For interrupt 0 and interrupt 1, we have 4 different modes. The low level, so interrupt will happen if 0 comes to interrupt 0. I have any logic change, so any logic change will cause the interrupt to happen. The falling edge and the rising edge, according to the value of ISC00 and ISC01. Exactly the same for ISC10 and ISC11, the same cases. For interrupt 2, I have only 2 cases. If 0 is written to ISC2, it's falling edge. If it's 1, it is rising edge. So only 2 states. For interrupt 0 and 1, we have 4 states. Now let's go to this code, and the question says, what does the following program do? So let's have a look on the program. So as you see, we have included 3 libraries or 3 header files. The AVR IO, the input-output header file, the utility delay, because we are going to use a function delay, and the AVR interrupt, because we are using the interrupt functions. Now we have this function. So this function is ISR. It's interrupt service routine. So it's taking vector int 0. So that's mean when interrupt happens on interrupt 0, this function will be called. What is this function doing? It's simply, here we have XOR with pin C0 1. So this is toggling. So actually we are toggling port C pin 0. So the pin 0 of port C. Then we make a delay. So when an interrupt happens, if we have an LED connected to port C, it will be toggle. If it's 1, it will be 0. If it's 0, it will change to be 1. Now the main program, as you see here, while 1, nothing. So actually our main program do nothing. So here just we do some initialization. First initialization, we set pin 0 of port C as output. So this set 1 to pin C0 in DDR-C. For DDR-D, we make sure that pin 0, 1, 2, 3, so pin 2 and 3 are inputs. The other no change, because we are making masking with AND. Now this is called BD2 pull up resistor. So you remember, here I make it as a remark, this actually can be replaced with programming pull up resistor. If we write like this, we give 1 to port D pin 2, that means it will be always 1. When I push the button, it will change. So no need to make this circuit if I write like this. So this is called pull-up resistor using the program. So instead of using pull-up resistor as in this figure, Atmega have what called built-in pull-up resistor. So this code will replace this circuit. So here we enable the BD2 pull-up resistor. Here we clear the global interrupt and then we set it again. So you can use like this. We can use S register, status register, pin I to be 1, or we can use SEI. So these three options do the same. In GICR we enable interrupt 0. So in GICR here we enable interrupt 0 by giving it 1, as you see here. Finally, in MCUCR, I make ISC 01 to be 1. So in MCUCR, I make 011 and 00 will remain as it is. So we are using this case. Okay? So it is interrupt 0 falling edge. So when the states change from 1 to 0 on the interrupt pin, the interrupt will happen. What will happen when the interrupt triggered? This function will be called. So when this function called, the pin C0 of port C will toggle. One remark before we move to the circuit: sometimes when you use port C for the first time in your microcontroller Atmega 32, you may face this problem. If you connected LEDs to port C, sometimes BC4 and BC3 get no output. BC2 and BC3 pins continuously given low brightness because they have low voltage output, less than 2 volt. Even if you apply 0 or 1 on the output, it will not change. It will still giving very low brightness. To solve this problem, make sure to disable OCDEN fuse and disable JTAG enable fuse in the fuses, as I will show you later when I move to show you the hardware. Now let's move to the simulation and show you how the circuit is working. This is the circuit that I am going to use in all the interrupt examples. As you see, we have 3 buttons to trigger the interrupt. One button is connected to interrupt 0, another button is connected to interrupt 1, and the third button is connected to interrupt 2. Then we have port C is connected to 8 LEDs. In this example, we care about LED 1, which is connected to BC0. Okay? Now we need to build our program. So we go to AVR Studio. I already write the program in a new project, C project, not assembly of course, and we build our program. So after building succeed, we go back to the simulator and we upload our program, the hex file, which is generated after building our program. We click OK and run the simulation. So now when I push button 1, which is interrupt 0, the interrupt is enabled. So when I push the interrupt enabled, the toggle happens. So as you see, every push it will move from positive to negative, from 1 to 0. So every 1 to 0, falling edge will change the status of the LED 1. So this is a very simple example to show how the interrupt is calling the ISR function to change something in our circuit. The hardware implementation, I connect the board and the programmer probably, as explained before. Now as you see, I connect the pins of port C. So this is the pin of port C to the LEDs, and then the pin BD2, which is interrupt 0. So BD2, which is interrupt 0, is connected to button K0. Now if you have a problem of port C, before uploading the program, click AVR programming, apply, read, and go to fuses. Okay, fuses is not a good place to play around. You just make sure you do exactly what is needed from you. So in fuses we have, as I explained before, make sure the OCDEN fuse and JTAG in fuse are disabled. So here in the fuses, you see there is one fuse JTAG EN and OCDN. Make sure they are not stacked. Then you will have no problem in port C. That's in case you have a problem in port C. If you don't have this problem, no need to worry about the fuses. Now we go to memories and upload the program. After uploading the program, the implementation, when I push key 1, interrupt happen and LED on. Push again, off, because of the interrupt. Thank you and see you in next video.